time we go. I am Neelam. We have used the laser patterning technique to turn this freestanding graphite oxide film into an energy storage device. We're going to use the CO2 laser beam to write on it, write some cute pattern on it. And after we did that, we can get some supercapacitor devices.
Supercapacitors is an energy storage device that complements batteries in terms of power delivery.
All these patterns, they are comprised of two separate parts, acting like two electrodes in supercapacitor. The most important finding we have here is freestanding graphene oxide film turns out to be a good ionic conductor. And we are going to put it in the laser patterning chamber. Now we have put the graphene oxide film into the laser patterning chamber, and we are going to use the CO2 laser beam to write some pattern, previous designed pattern, onto our graphene oxide film.
It's really dramatic.
Now we have a supercapacitor structure on our original graphene oxide film.
So supercapacitors are electrochemical capacitors, and these have much higher energy density than typical capacitors. Also, if you compare with batteries, they have much higher power density. So in all these hybrid cars and other devices that people think about today, in order to deliver a lot of power in a short pulse, you probably need to combine the regular battery with the supercapacitor.
We have two capacitors, one commercial one and a supercapacitor in my other hand, and the capacity of the two guys are almost the same.
So what we have done, of course, compares not with the bulk supercapacitors that would be used in the automobile industry, but more on a micro scale platform. Of course, this process is so scalable that you can make very large number of these in an array and connect them together, and ultimately you could get pretty good power. But essentially, the focus, if you look at the single devices, is at the micro scale.